Solving simultaneous equations with three variables. X plus y plus z is equal to 6 is an equation with three variables, three dimensions. To plot this equation, we need three axes, x, y, and z axes, at right angles to one another. When plotted, this equation represents a plane of points. If three planes are plotted on the same axes, there will be one point of intersection, x, y, z, provided none of the planes are parallel. To solve an equation with three unknowns. Step 1. Reduce the three equations to 2 by eliminating one of the unknowns. It's typically z we will eliminate, but not always. Step 2. Choose an unknown that is easy to isolate. Step 3. Eliminate this unknown from all three equations, taking them two at a time. Step 4. Solve these two equations as before. Step 5. Use your values for these unknowns in one of the original equations to solve for the third unknown. Step 5. Check your solutions in all equations. Example 3. Solve the simultaneous equations. X plus y plus z is equal to 6, 2x plus y minus z is equal to 1, and 4x minus 3y plus 2z is equal to 4. It's easy if you label them A, B, and C. So step 1, we're going to eliminate z from all three equations. So I'm going to start with the first two equations. So I have x plus y plus z is equal to 6 and 2x plus y minus z is equal to 1. You can see that the z's will straight away cancel. So we have 3x plus 2y is equal to 7. We're going to call this equation D. Then we'll take equation B and equation C. So we have 2x plus y minus z is equal to 1 and 4x minus 3y plus 2z is equal to 4. I'm going to multiply B, equation B, by 2 so that I can cancel out my z's. So I get 4x plus 2y minus 2z is equal to 2. And equation C in green just stays as it is. And you'll notice that minus 2z plus 2z will cancel. So I'm left with 8x minus y is equal to 6. I'm going to call this other new equation, equation E. So now I'm going to take equation D and equation E, which don't have any z's, and I'm going to solve for x and y. So now solve D and E simultaneously. So there's equation D and equation E. I'm going to multiply equation E by 2 so that I can cancel out the y's. So I have the original line D, 3x plus 2y is equal to 7 stays as it is. And the second line E becomes 16x minus 2y is equal to 12 because we multiplied by 2. Now the y's will cancel. And I have 19x is equal to 19. So x is equal to 1. So now I have x. I'm going to sub it into one of the equations to find y. I'm going to go to equation D. So I have 3x plus 2y is equal to 7. I replace the x with a set of brackets and put 1 into the brackets. So I get 3 times 1 plus 2y is equal to 7. So 3 plus 2y is equal to 7. 2y is equal to 7 minus 3. 2y is equal to 4. So y is equal to 2. So now I've found x, I've found y, now I have to find z. So I go back to my original equations and I pick one of them. So I'm going to go with A, just because it's the simplest. And I'm going to replace the x with 1, the y with 2, and then I can solve for z. So I have 1 plus 2 plus z is equal to 6. So z is equal to 6 minus 1 minus 2. So z is equal to 3. So x is equal to 1, y is equal to 2, and z is equal to 3. Example 4. An opera was attended by 240 people. Two ticket prices, €31 and €16, were available. If the total takings on the night were €5,595, find using this data two linear equations connecting the two types of tickets sold, the number of €31 tickets sold, and the number of €16 tickets sold. So for part 1, we're going to let x represent the number of €16 tickets sold, and we're going to let y represent the number of €31 tickets sold. So since 240 people attended altogether, then we can say x plus y is equal to 240. So I have created this equation in terms of x and y. So I have x plus y is equal to 240. 240 came from the question. And I'm calling this equation A. If the receipts were €5,595, then 16x plus 31y is equal to 5,595. So I'm calling this equation B. So 16x plus 31y is equal to 5,595. Because I know that x represents the number of €16 tickets sold. So 16x, it's going to be €16 times the number of tickets sold for €16. And then I know that I let y represent the number of €31 tickets sold. So 31y stands for 31 multiplied by the number of tickets sold for €31. So adding these and letting it equal to 5,595. So part 2, I'm going to take equation A and B that I created in part 1, and I'm going to solve them simultaneously. So I'm going to multiply equation A by minus 16 so that I can cancel out the x's. So I get minus 16x minus 16y equals minus 3,840. And then I'm going to write down equation B. I'm not going to change anything. I'm just going to write it down as it is. And then my x's will cancel. And I'm left with 15y equals 1,755. So y is equal to 117. Therefore, 117 €31 tickets were sold. So now we need to figure out how many €16 tickets were sold. So part 3, I'm going to go back to equation A that I created at the start. So x plus y is equal to 240. I'm going to replace the y with 117 because we know that y is equal to 117. So x is going to be 240 minus 117, which is 123. So therefore, 123 €16 tickets were sold.